So what's on today? It's the fifth module of the learning journey on hazard assessment, and you have noticed that we adjusted the webinar series for this first part. We did that based on feedbacks in the different evaluations and decided to add one more module. I hope that's okay with you. In this fifth module, we will go a bit deeper in the floods assessment with a focus on hazard mapping and how to do that practically in the field. We also have a look at how to embed the hazard assessment in programming in general. That's also, this second part is based on your feedbacks that you wanted a bit more of an introduction. And then and I will not go much more into detail because that's Georg's business, of course. He will come to that just in a second. And module 6 will then be on hazard assessment landslide, and we will end with a Q&A session on all modules, on hazard assessment in general, on your questions there. Again, the second part then of this learning journey will focus on risk assessment and cost-benefit analysis with so far 3 webinars that we have planned, and we have planned them for the beginning of 2024. And that's it from my side, and I give the floor to Georg. Please go ahead.
Thank you, Tony. A warm welcome also from my side. I'm trying to share the screen and then we will be able to start. So, does that work for you, Tony?
Looks good.
Okay. So, the topic from today will be still floods. It will be the hazard mapping and one step in direction of risk analysis, which means defining of critical sites. In the learning journeys before, in the modules before, you learned several tools. You have the acquired knowledge. So today will be the opportunity to practice it by yourself. We'll build groups, and then you have a case that you have to resolve. 2 cases to resolve, and I will jump from group to help if there is a need. So as the content says, practice hydrology and hydraulics to define the discharge capacity of a stream, to define where outflows could occur in a stream. The second content point will be how to map the hazard-prone areas outside of the stream. So that was also a need from your side to explain more in detail these working steps to get, as the final product, the hazard map as we see in this picture, as you have seen before also in other modules. And then what I meant before, the definition of critical sites. Critical sites means points of interest where you have to make efforts in your project to reduce the risks or the probability to get damages. Just to give you an idea what means the first exercise, I will introduce it afterwards, but that you have in mind what's the problem that you have to solve in the first exercise. And this is a picture taken from a part of a village in Switzerland. You see on the central left part the stream, a small stream, maybe 4 meters wide. You see the flow direction indicated by this blue arrow. You see a bridge, and the question for these 2 houses under which scenarios these two buildings will be flooded. And I can say that in advance, they are hazard prone, so they will be flooded in some of these scenarios, 10 yearly events, as you see on the right side here, down here in this matrix, or in 30 yearly events, or in extremely 100 yearly events. So you have to define on which scenarios these two buildings are flooded. And as well to give more information about the flow height and the flow velocity of the outflow in the area of these two buildings, and to define the intensities of this of flooding on these two buildings. That means this part on the matrix on the left side, high intensity, where people will be driven away and will die. Medium intensity, that means they can resist. Adults will be able to resist if they can hold on a fixed point. Or just low intensities where, yeah, maybe flooding until your knees or even less. And at the end, define what is the hazard level of these two buildings, which kind of numbers we will apply when we are mapping the hazard, the flood hazards. And I'm sure you'll be able to respond to those questions, because they are what we learned before. But to answer the questions, I would like to give you a very short introduction, looking back from the other learning journeys of the modules. First of all, we have to define for the relating catchment the peak flow for the three scenarios, 10 yearly, 30 yearly, 100 yearly events. For that, we need to know the catchment size, the steepness of the catchment, for sure the land use type, if it's forested or without any vegetation cover, or it's maybe an urban area where the infiltration of water won't be possible or almost not possible. The soil type, if we have a very profound soil or just a shallow soil cover, is it clayey or sandy soil? We have to define that. It's the most difficult working step for defining peak flows. And then also it depends on the length and the density of channels. So how to calculate these peak flows? For that, you have the access to Augur. And you know already this website where you can access Augur. I will just open it. And as we are not that much person today, so it will be easier. It will be hopefully go faster, Augur, as the performance of the tool is not already the best. When you start it, it will open the Spanish version, so you have to switch to English with these three lines. On the left side, you have to scroll down a little bit. Okay, cambiar idioma. We switch to English. Done. So I can close this window on the left side with these three lines, clicking on the three lines. So first of all, I have to look for my catchment where I would like to know the peak flow. It starts always in Switzerland, but you can zoom out, zoom in to your area. Be care about that Augur is limited to catchment sizes until 300 kilometers square. If you have a bigger catchment size, Augur will give you an answer, a response error, an error message. So I will zoom in to have peak flow of this catchment here. It's very important to zoom in to be sure that you are clicking on the channel and not out of the channel. In that case, we are in a village. This is the stream. The flow direction is from up to down. So I would like to know peak flow in this area here because I would like to map the hazards for these houses here. So I put my hand on the channel, I click on it, and then I can delineate the catchments to define the catchment size. So this takes a moment, maybe 20 seconds, it depends, maybe a little bit more. You have just to wait a while. Okay. It appears processing message. Okay, done. I zoom out to see if that makes sense, if it defined the catchment as I thought it will do it. Yes, it is. It's a very long catchment in this size, in this case. So Augur gives me some information gathered from the delimitation of the catchment. For example, the catchment area. Automatically, Augur defines the area and gives me also the length in meters of the main river, the main channel. So here I can make modifications, but I shouldn't. The next step is to define the soil type, which I mentioned before. That's in some cases a little bit difficult. You have to go to terrain, or you have reports, information about soil type. To make it not too difficult, we at the moment just defined, we are distinguished four soil types. That means a deep soil where the soil cover is more than 40 centimeters. Soils which have a shallower soil cover are mentioned as superficial, high permeability, or if you have a clayey soil, slightly clayey, or even strongly clayey. In that case, as I know this region, I know we have a superficial soils and clayey mixed, but a little bit clayey underground. So I activate this soil type. You have to consider if your catchment is in a very steep area, in a mountainous area, or it's just flat or intermediate. In that case, it is characterized by hills, this catchment, so I put just moderate. If I would like to consider a climate scenario, a climate signal, I can switch from the today situation to how could it be the peak flow regarding a climate change scenario by 2090. I just use the actual climate situation. And then here on the upper side of this window, I have to define the land cover. This is not that difficult. You can work on the screen on what you see on your left side on the satellite image to define the percentage of forest. Here we have forest areas, and we have also pasture area. In that case, it's almost 50-50. Forest land cover, a little bit less of pasture, 40%, and about 10 more or less. It's not that sensitive, the definition of the land cover types. 10% of farmland, there are no debris areas without any vegetation, it doesn't exist here, and settlement areas is almost zero. If you go higher than 100%, you will receive also an error message. That's all that I have to define for Augur. I switch back to the parameter window, and then I can compute the discharge. And as you see on the hydrogram here on the upper side of the screen, the form of the hydrogram doesn't change, but the values of the curve depends on the parameter you introduced, you used. So for the 10-yearly event, the peak flow is 24 meter cube per second. You have the 30 scenario of 30 years of return period, and for the extreme event with a return period of about 100 years, there is a 41 meter cube per second. So that's all you have to know about Augur. You will work with these three values of discharge, 24, 32, and 41. So this is your result you need to go further on with your analysis. I switch back to the PowerPoint. The next step will be on the point where you calculated the maximum discharge. Is the channel able to receive this peak flow without outflows? So what's the discharge capacity of different points along the river? So I just click on this site, and it opens me as well the website from Augur. You scroll a little bit down, you have to activate Augur flooding, and then it opens you an Excel with the hydraulic part. That means what I mentioned before, the discharge capacity of the specific point of your interest along the river. Here at the beginning, in the first column, you have to define the name of the river, of the water course. Maybe you have a specific reference point of where you are at your point of interest. If you would like to put also the altitude above sea level. These are not really mandatory to enter information, and the Excel won't calculate with these three columns. But for the next column, it depends really on the result. You can define, or you have an open channel, or as I showed you in the examples before from your exercise, you have a sewer, you have a bridge, you have an obstacle where you would like to define the discharge capacity. Once you defined your channel type, the gray cells, you don't have to fill out anything. You can just, okay. You have to enter information on the yellow cells. That means sewer height. I give you an example, maybe 4 meters. The width of this sewer of the bridge is about 8 meters, and the slope of the channel at the point where you are. There is a possibility to use GIS when you have a digital terrain model, what's explained Andrea in a further module, or you have a measurement in a clinometer where you can measure the slope. These are instruments you can buy, or even you can also download a free application on your cellular phone that you can use in terrain to measure the slope angle, which it has to be in percentage. Again, make it a little bit bigger. Okay. So you have also defined the rootedness of the channel at the point you are, or of your interest. That means the root of the channel, the lower the velocity. For rootedness values, you can just use the other layer of the Excel, where we have different examples, 6 examples to define the rootedness value. For example, a very root channel is you have rootedness value about 10 to 15. If you have a channel built by concrete, for example, the rootedness is very low, so the value is higher. So just you can use this orientation to define the rootedness value. I switch back to the hydraulic sheet. Rootedness value is already done, maybe 25. The peak flow. So here I have to enter the auger values. Was it 24? 42, I can't remember well the values we had. I make an extreme peak flow for the 100-yearly event. Is not really realistic in that case, but just to show you, make it worse. 200 meter cube, and you can see on the right side on the results here the flow velocity, if you are interested in this information, in kilometers per hour. The maximum discharge that the river at your point of interest can support or can hydraulic capacity. Sorry, I don't have the exact word for that in English. It shows you here for these 3 scenarios for the 10-yearly events that you are on the green side. That means you have still almost 100 meter cube per second left. So you will have outflows for these scenarios for the 10-yearly scenario. For the 30-yearly scenario, neither, but for the 100-yearly extreme event scenario, you will have an outflow of 81 meter cube per second. If you have not a sewer, but you have an open channel, you have to enter some different information. That means the geometry of your cross section. I won't go to details. That's what we learned before. You have to define width, length of limiting embankment, and angles of the cross section. The rest works identical. Let's say, for example, 5 meters riverbed, 4 meters length of limiting embankment, angle of limiting embankment 45 degrees in that case. The other may be 40 degrees, and it gives me also information about the discharge capacity. Okay. I go back to the PowerPoint. So at this time, I have already defined peak flows for these 3 scenarios. Could be here or here or here or here. Different points of interest. I have defined the discharge capacity along the river. That can be very difficult, each 100 meters or each 50 meters. That depends on the stream. In that case, the geometry of this river is almost the same, so I don't have to measure many cross sections. If it's very variable, the geometry of the channel, I have to measure many cross sections, at least those where I think could be limiting the discharge capacity. I have to measure the length and the width and the width and the values we saw before. So you have to define first for the 10-yearly scenario the weak points along the channel. In that case, I found 3 weak points. For sure, I measured many others, but I recognize that just these 3 points are weak points. Once I have defined these weak points, I have to define the flood-prone areas. That's a working step I will show you more in detail in a couple slides further on. In my case here, for sure, I have high intensities in the channel. That means higher than 2 meters, or the product between velocity and flow depth is higher than 2. But on both sides, the flooding-prone areas shows me just low intensity. So the result for this scenario of 10 years will be just a 3. Inundation, inundation intensity level 3, or hazard level 3. So this is like a hazard map for this 10-yearly scenario. I have to repeat the same for the 30-yearly event. So maybe I have the same weak points along the channel, but in that case I have a new weak point here. And I have to define the flooding-prone areas. Why do we change from blue to yellow? It's according to the 9-field matrix, as we are in this area here, in the purple area, 30-yearly events, if you have low intensities, as I have in that case, it's the number 2 of hazard level, and hazard level 2 is yellow. So that's the reason why I'm using the yellow color. I have to repeat the same working steps for the 100-yearly event. You see I have the same weak points as I had before for the 30-yearly event. And I make the same. I'm defining the hazard-prone areas. In that case, it's yellow as well. It still remains on low intensity, so inundation hazard level 1. So at this moment, you have like 3 hazard maps for each scenarios, and the final product will be just 1 hazard map. So what I have to do is to merge these 3 I say scenario hazard maps to just 1 hazard maps. And that means I take this from the 10-yearly event, I aggregate additional flooding areas that has not been covered by the 10-yearly event. That means I aggregate these 2 yellow parts. For sure, in the blue part for the EN3, it will be also affected by inundation 2 for the 30-yearly event. But as the blue area is worse than the yellow area 2, the 3 wins. So I can see the yellow part in that area here. The same I have to do including the extremely event. So I just have an additional flooding prone area, which is here, where I have to add this inundation 1 for low intensity 100-yearly event. The rest is on the same classification type style. I have in this inundation 3 area as well inundation 2 and inundation 1. But as I mentioned before, the worst number wins, and that's the reason why it remains blue here. On the main channel, I have always high intensity for each scenarios. So I have flooding inundation 9, 8, and 7. And this 9 wins. That's the reason why it's at the final product, it shows me just inundation 9 without showing the other scenarios in the final product. So that's the final product that you can use for the following project working steps. So now you know where the hazardous areas are, you know the houses within flood-prone areas. You can use that for your land use planning or for mitigation measures, organizational mitigation measures, or even structural mitigation measures. But it's your product you need to go further on to apply the right mitigation measures. Let me just explain. I'm just looking the watch, already half an hour. Last point, before you start in your exercises, I promised to explain you more in detail how to define the hazard-prone areas outside of the stream. First, I know for example, the 10-yearly event, the discharge, in that example, maybe 15 meter cube per second. That's what information I get from Augur, 15 meter cube per second. That means 15 boxes with 1 meter on each side, 1 meter high, 1 meter wide, and 1 meter, one per 1 meter. Then I calculated with the Excel the discharge capacity. In that case, maybe it will be 10 meter cube per second. So 5 meter cube per second will flow out of the stream and flow along areas that's where the water can flow regarding depending on the topography. In that case, this 5 meter cube per second flows in this area here. It's like normally a dry channel with a width of 20 meters. So how to define flow depth, how to define intensity level, and at the end, the hazard level. For that, it's a simple calculation. You have the flow height written in red, as it is the question here. You can define it by the outflow volume, which is 5 meter cube per second, divided by the flow width, in our case 20 meters, and divided by the flow velocity. So how we know the flow velocity? We don't have done any two-dimensional modeling, so where to get this information? There are some more or less definition of flow velocity to make it simple. A very simple one can be, and it is used from many engineers as well, in flat surroundings outside of the channel. If you have flat surroundings, you can work with 1 meter per second. That is the velocity of a person walking, normal walking, or the double, 2 meter per second for steep surroundings or areas where you don't have any obstacles. No trees, no forest. Yeah. So if you work in this flat area with 1 meter per second, I take outflow 5 divided by flow width 20 meters. That means 25 centimeters, if I calculate it right. So that means 0.25 meters divided by the flow velocity divided by 1, if it is a flat surrounding. So that means the flow height is 25 centimeters. And what means flow height 25 centimeters? We discussed these 3 intensity levels. If it is less than 0.5 meters, or flow height multiplied with velocity, 0.25 multiplied by 1, it remains 0.25, so that is less than 0.5. I'm considering the 10-yearly event, so intensity is low and the hazard level is 3. That means blue. And that's the reason why I'm defining this area as inundation 3 hazard degree level area. For this working part, you have to go to terrain, so you can't do that on your screen. Okay, so that's all what I want to give you as introduction. Sorry for this long introduction, but you will have time enough to do these 2
Georg,
exercises.
I'm interrupting you here. Can you go a slide back, because I have a question in the chat that I think is very important, and I would like to give all of you also just well, just okay. No, the slide. Keep the slide, please, Georg.
Mhm.
The last slide that you had. Cindy, she asks, how do you know where the weak points are?
Okay.
How do you know that? And then I
Yeah.
after that, I invite all of you, just if you have any questions with regard to what Georg has been explaining up to now, just go ahead.
Thank you for this question. If I see that my channel remains its geometry, so it doesn't change, I just take one cross section because it's on every point, it's the same situation. Once I recognize that maybe here the geometry changes, so that's the moment I take another cross section. So all in at every point where you can see that the channel geometry, that the width, for example, is wider, or even on the upper side, we have less space for the flow capacity. I take another cross section. I measure another cross section. In that case, that example here is always the same. So I take here maybe one, and then I let it be. Maybe here it changes a little bit along the forested area. I take another cross section, but if it remains, I won't change. It looks this event shows me that here is probably changes the geometry. So I take here one more, and on the on the upper side, it depends how this channel changes its geometry. But it's possible that along 1 kilometer I can work with just one cross section, or with 10 cross sections.
So,
is that okay for you? The answer of this question? You have to give me an answer, Tony.
Yeah, but I mean, Cindy, she would open the mic and talk as well. For me, so if I understand correctly, when it narrows down, or if you see, and you have to go in the terrain, otherwise you will it's very difficult. You need to have very sophisticated modeling to understand that. But it's always best to go to have a look in the terrain. There you see if the riverbed is lower than before, and then you say, okay, this might be such a point where you measure it. And I would assume that if we would see a bridge here, you would also assume that, well, bridge is important. That might be a critical site. Who knows? Let's also measure at this point, probably, huh?
Yes, bridges are always measured.
Okay. Cindy, is that okay? Oh, she's writing. So she says, so the weak points are the same points where the geometry changes. I leave that to you, Georg.
Yeah, that's correct. At
Changes in a
least,
way, in a way that where you see that, okay, the capacity is less. If it changes in another way, where it gets, where you have a higher, how you call it, riverbeds, or not riverbeds, but the walls besides, then of course you don't measure there because you see that there the capacity would be higher than before. But in
Yeah.
that case, yes, where you see it
If
from
it's
the
obvious in terrain, you don't have to
uh-huh,
measure it. Yeah.
May I ask a question that's aligned to that one? This is Jana. Hi.
Go ahead, please. Yeah.
So if we like as a rule of thumb, so when we look at this a section of the river, can we say that, okay, you said bridges, so every bridge we need to check. Also areas where the river changes its course, so because you highlighted basically the weak points always where there is kind of a curve in the river, right, where it changes direction. Is that also an indicator, or could you give us, let's say, as a very rough rule of thumb, which would be, just from a photo, also when I stand in front of it looking at the river, which would be points I definitely need to look at? Because maybe I'm not so familiar with how does it look like when geometry changes. And I cannot maybe not look into the river. So are there, let's say, indicators on the surface that can guide me to identify the weak points?
Yeah. Changes of river courses is not a criteria to measure the geometry of the channel. It is, for example, you have I told you have to help me with the translation. For example, a Schwelle.
Oh, an obstacle in the riverbed. Huh?
Yeah, for example, an obstacle or
like a piece of how you say that, like a step, huh? Like a step in the riverbed. No, would be
yeah,
a
yeah, for
schwelle would be like
example.
a step, huh? That
Mhm.
breaks the velocity.
Exactly. It can, but it can also be changes of the inclination. That is also a criteria that you have to consider. For example, if you have measured a cross section on a very steep section, and then suddenly the slope is reduced by the topography, so the discharge capacity will be less. So there you should take a cross-section measurement as well. If you're looking for points where from the screen you can define weak points, or points where you have to measure, these are, as Tony mentioned, the bridges. You are always measuring bridges. But on the other points, yeah, changes of slope, changes of angles of the just give me of the embankment. So yeah, changing of the length of embankment. These are criteria, Jana, but there are no, as I said, hard factors where you have from the screen you will be able to defining weak points. That's not
Another
possible.
question I see from Thomas, what about the high trees on both sides of the riverbank, like we see here in this picture? Does that have an influence?
Yeah, it can have an influence regarding the rootedness of your channel. If the trees are outside or just on the top of the embankments and outside of them, it doesn't have influences on the definition of weak points. It has an influences the hazard-prone areas. But to define the weak points, if the vegetation is within the cross-section area, there the rootedness can be reduced. And that for velocity is reduced, and that means that the flow height in the channel will grow. Can you show that here? Just give me a second. So the outflow will be the same. The outflow will be the same, or the discharge will be the same. If the flow velocity will be reduced by trees and forest vegetation, so the flow height in the channel will be higher. Are there any other questions?
Yeah, just one from my side. A last one, because if I look at this picture, that could be somewhere in the Emmental or so, where I know that you're very familiar with, and doing that was your daily bread for a long time in your career. And seeing that, what we see there, that's an event, a hazardous event. And when you do the hazard mapping, when you go there as an expert, would it also be an idea just to ask, to ask people around there, do you remember the last time when there was flooding, where were the weak points? And then you also that also gives you an indication. You don't have to look for long, you just know, okay, here and here and here, and probably that would help. That would be more efficient. Or is that a no-go?
This is not a no-go. On the contrary, this is very, very, very important, Tony. I think in the first module we talked about one of the working steps is to gather information, could be written in newspapers, information you get from VCAs, or other sources, photos, for example, as we see here. It's really very important to have information about earlier events. It helps you to calibrate your result. So when, for example, you are doing a hazard map and you see just this area as flood-prone areas, and then you see in a photo that this part has been flooded, so you are sure that your hazard mapping is wrong. So this is a very important working steps. Once you see that the information that the people on site gives you matches with your technical working steps that we have seen now, if it matches well, that gives you a more security that your final product, your hazard map, is well done. There's another working steps that we mentioned before also in the first module. This is the transect walk to look for silent witnesses, hidden trees, plastics hanging on trees, erosion of both sides, maybe outside of the channel. So this signs that you can find in terrain is the third aspect we have to consider for the hazard mapping. In some slides further on after the exercises, Tony, we will repeat as well these two working steps. I say the VCA part, or the event cadastre, and also the transect walk. Is that okay for you?
Right. Yes.
Okay.
So just a question, I'm sorry if I'm moderating a bit too much here, but we've been now, it's almost 2 o'clock. Would it be okay for you, that, and would it be okay for you first, Georg, if we only do one exercise now and leave the other exercise individual for the participants that they can do between now and module 6? Or, and that's to all of you, to all 13 who are participating, do you have more time than 3 o'clock? Would you like to work more in groups, and then it will be at least 3:30 at least? Would that be still okay for you? Not for Jana. So many cannot stay. So, Georg, if you agree, do we just do one exercise now? and the other one for is like a homework, for whoever wants to do it. Is that
That's okay? That's okay,
good.
but I will say that we will have 20 minutes for this exercise 1. Those who are very fast can go easily to exercise 2, but at least so we will have done the exercise 1.
Okay.
We see the catchment properties. Please look for brand oesch. You have to mention in Augur. The soil type is superficial clay, and the slope gradient is moderate. This is the 3 information I give you to fill out the Augur. And here you have the questions we saw before, that you have to give a response. It shows you also the geometry of the bridge, 5 meter the width and 2 meter high. It shows you as well, it shows you as well that this is not, here the reference point is 0 meter, and the bridge here has a reference altitude of 60 centimeters higher. So it's probably the water flowing out on the right side to the 2 houses. It shows you also that the outflow probably will be along the road, which is 4 meter wide. And you have an obstacle for the outflow, which is 1.5 meter high. So probably water won't flow out of the bridge. Yeah, I have just a last information that is not visible. Yeah, the additional information I give you is that the channel slope is 2%. It will be important as well for the discharge capacity for the calculation. On the upper right, you see the link to Augur. Yeah, and for those who would like to make the second example, it's in the same manner. I won't go to detail, as probably we won't get to exercise 2. So, Tony, is it possible for you to put the exercise 1 in the chat?
I put exercise 1 and 2, yeah, I put them in the chat. Have a look if it works.
In my case, it works. Hopefully for you as well.
I need some other.
It works.
Does it work? Okay, good.
It works, but slow.
Okay. Would it be possible to jump the break, or do you need to have a break? Tony, you could maybe check if you have some response in the chat.
I would say if all agrees, I would go for no break and now go directly in working groups. And as we are 13, otherwise because I know the program, people, I know it, and there's still more to come. And maybe we want to benefit more from working than from breaking. And you can make a big break at 3 o'clock. I would propose.
Okay.
I'm a bit directive here, and we are. How many are we? 11, huh? I propose to have 3 groups. Is that okay,
Yeah,
Georg?
that's what I would suggest as well.
Good.
And you'll get from now until 2 o'clock 2:20. So we have almost 20 minutes.
Yeah, we are back.
So we brought everybody back. Are there questions that you think we could discuss as we are the whole group now?
Well, we could see in which hazard level we are landing for the different scenarios.
Could you maybe, Jana, explain your working steps you have done and the result you got?
Okay. Yes. So first we went to Augur. Theo and me, we were a small group. And we took we calculated catchment and so on and derived the discharge. And then we entered the information into the hydraulic table. And initially we said it was an open channel, but then we didn't have any outflow. But Georg helped us saying that no, as the bridge is the weak point, it's a sewer. And then it made more sense. And we calculated that there is outflow at 30 and at 100-year events. So 2.3 cubic meters per second and 11.3 cubic meters per second. This is what
What's the outflow?
This is the outflow, exactly. So under which scenarios so they would be flooded under the 30 and 100-year scenarios. And then to calculate the flow height, you helped us a bit, Georg. So we took this 2.3 meters for the 30-year scenario, divided it by the height, by the width of the channel, which is the street. Those are the 4 meters, 2.3 divided by 4. And then this yielded 0.57 or 58. So 58 centimeters. This would be the flow height. No. Divided by 2, right? Oh, sorry. Yeah. Okay. So we got to a flow height of a bit less than 30 centimeter. And if we multiply this by the velocity, as we see at the risk matrix on the bottom, to calculate the intensity, then we reached again close to 60 centimeters. And that would bring us, because it's a 30-year event, to hazard level 5, blue, for the 30-year event. And when going through quickly, I don't know, I just did it now in a minute for the 100-year event, but then I reached 7, hazard level 7.
Ah, you reached level 7.
Yeah, 2.8 meters. But maybe I calculated something wrong. I don't know.
Okay. If it is 2.7 or 8 meters, which hazard level?
No, that's not the intensity. I don't know. Never mind. I'm confused with all the numbers. So.
Okay. Okay, but thank you, Jana, for this explaining the working steps. Do you have comments? Did you have other experiences while you have done the exercise?
But I would just like to continue from Jana there. You know, when you say like, when you have like 11 cubic meter overflow with in a 100-year event, then that would mean, you know, you would have those 2.7 meters flow height, and the velocity we would, what would you assume there? 1 meter probably.
Yeah,
1 meter per second.
Yeah,
that would,
probably. Yeah. Okay, go ahead.
That would then mean, you know, we are above 2 meters intensity there, or above 2, and we are in a 7. But in a 7, you know, that's a bit, for me, you know, that would be strange to have a 7 in the middle of Switzerland there, huh? For a 100-year event. So I could not really relate to that. Huh?
Yeah.
And I wanted to ask you because we've done the same. And when we took the data, you know, that was on the exercise that you already did for the 10, 30, and 100 years event, we came to the same results. And and Niraj said, "But hey, listen, I've done it. You know, I went to see the capacity, the discharge capacity, etc. I went to do it, and I had slightly different figures, slightly lower figures there." We only had an overflow. We only have a flooding in a 100-year event, and they're just level 4.
Huh. That's
So
interesting.
that was a bit my question there, you know. And if I take the data, you know, that I see on the exercise, 25 cubic meters for the 10, 31 for the 30, and 38 for 100, I get to those same results. I don't know what results you have, Georg. But to me, it was to be on 7 on a 7 intensity. That was I thought, you know, we would not have that in this context.
At the moment, for sure, we need to practice more. It would be best to practice it in terrain. I think at the moment it's enough to know the working steps. If the result is right or not, that would be, I would say, another discussion to analyze well which parameters you applied, etc., etc. But I think it's enough at the moment to know the working step for that. In Switzerland, we do have many houses in the red area.
For a
As you'll
100-year
see,
event.
sure,
Okay, okay.
they are, and especially in this region,
Okay, okay.
they are. But
does it correspond a bit to your results, Tony, and also Jo and other groups? Or
I was with
what?
you and Niraj. Yes, it corresponds to a bit. You know, we had the same, right, Niraj? What our take was, we need to be quite careful with where to point the point of interest, as you said in already in module 3, and maybe do it several times. This calculation with Augur for the discharge capacity, because it's so important. Then when you use those data for your results, then on flooding, I think you need to be very careful there.
Yes, I think that was.
And probably make a plausibility check, and, you know, cross check with data from the communities. I think that's very important.
Exactly. It should match to be at least for the 10-yearly event. It must match, because 10-yearly events, elderly people probably will have lived during 50 years there, so they will have had 5 times a 10-yearly event. So that you have to compare. For 30-yearly event, maybe you can also use the experience of local people. For 100-yearly events, probably will be difficult. But once you see that your results, your technical results, don't match with what the people saying in these 2 houses of their experience, so you know you are wrong. Could be because of the finding of peak flow or other params you have to adjust. So always compare your results with silent witnesses. That is for floods, it's a little bit difficult because normally you won't see that, but for landslides, rockfall, and debris flows, you will find almost always signs, sometimes for floods as well. These 3 aspects, methodological aspects, you have to consider all of them. Silent witnesses, technical analysis, and asking people about their experiences. If you had problems, or if you see that in your project this is too difficult to do the working steps that we use for the exercise, there is also a possibility just to limit your calculation for the definition of weak points along the river, and the outflow to say yes or no, affected or not affected, without defining yellow, blue, and red areas. We use the application of the 3 colors if you would like to have a real hazard map. But for some projects, maybe it's just enough to say, yes, it's a hazard, it's a flood prone area or not. So it depends on the knowledge you have in your project. Responding to Jana, the high intensity, probably it will be reduced to a lower intensity because with higher than 2 meters flow height, the water will flow above the wall, and will also flow above the bridge. So the flow width will be much bigger, and that for the flow depth will be reduced. So you probably will be for the 100-year event as well in the middle intensity.
Okay, because but I would, but that surpasses my capacity to calculate.
But Jana, you know, if you look at the reference point on the left side in this exercise, where you have 0.6 meters, of course, once your flow height is more than 60 centimeters on the 4 meters on the right side, then the water will also flow on the other side. We didn't think about that. I didn't think about that.
But I don't know how to calculate that. Then I would have to make a distinction between the flow height. I mean, so until 2 meters of flow height, I would have 4 meters of channel width, and then everything that's above 2 meters, I would have, let's say, 10 meters of flow width.
Even will be much more.
Yes,
even much
it will be much more. So in
we
that
don't
case,
see the other side, huh?
Yeah, I would go on the simple way to say, well, I don't know exactly the flow width because of really difficult. It flows above the wall. It flows on the left side of the bridge. So flow height will be really low, probably less than 50 centimeters. I'm not really sure about that. If I would like to be really sure, I have to apply a 2D modelization, which we don't have the possibility in a project normally. So just go on the more or less will have probably a middle intensity, and you work with the yellow 4. So we lose precision because it's too complex.
Yeah,
but
already
we have the possibility to define the hazard level as well.
Dirk, one question at this point, which I wanted to put before also, as in the example when you put the PowerPoint, you put as the overflow, the width at 20 meters. And then we calculate the flow height, and the velocity is given. And then we calculate the flow height. Isn't it recommended then to recheck again that given the calculated flow height, the outflow, the width of the outflow is still the realistic one?
Oh, sorry, I didn't check it. You said to recheck it, but can you explain it one more time, please?
Yes, just in this example which you're presenting now, we have 20 meters of the width of the outflow.
Yes.
And then we calculate the velocity and the flow height. And then if we have the flow height, isn't it then recommended checking that at the calculated flow height, the estimated flow width is still realistic? As in the example we just had right now with the bridge, where we at first thought, okay, it will be 4 meters, but then calculating the flow height, we see, okay, but then it will overflow the wall, and then it will be much wider.
Yeah. And now I understand your question. Yes, if you have flow paths which are not really clearly defined, it makes sense to recalculate, to recheck with this defined flow height if the width will be the same or not. That makes sense, and it has to be done as well. But it's all, we are almost entering in advanced level of hazard mapping. But it's right what you are telling, that you have to consider as well. But at the level we are just seeing that for the first time. I consider to define a clear defined width for the calculation. But your comment is right.
Okay, thank you.
Are there other questions? Okay, I just go ahead to show you how we applied this hazard mapping in a project in Honduras along the PCM. Well, you see on the right side the area with the black line. You see the project area, and this was a second phase of a project. And in the first phase, people or project has already done in several villages a VCA, which we could use for the assessment. And we had available a very, very, very rough estimation of floodable areas, which is shown here in blue, from Swiss Re. Swiss Re has the so-called CatNet, which is a modeling of hazard-prone areas, but on a worldwide level, which means a very pessimistic and a very unprecise calculation, but nevertheless, it could help us. So this CatNet, you can access CatNet as well, partially, not the whole options. So if I sign in, I can show you some CatNet data. Send push. Where did I get the information? No.
Georg?
Yeah, I just jumped that.
Yeah, I'm a bit directive looking at the time.
Yeah.
I think you will get the slides very quickly tomorrow at the latest, and then you can go yourself there, and probably in the module 6 we might come back to that quite quickly.
Yeah.
Huh?
Okay, so at the assessment phase, it would have been necessary also to realize not the hazard mapping, what we have done before, but that was not possible during the time we had available for the assessment phase. So that the hazard mapping had been done during the implementation phase. But for the assessment information we had, we could do our planning or our design of the project, where we defined outcomes, outputs, activities, considering hazard and risk mapping. What I think it's important to mention, normally you see here the 5 working steps that you can find also in the guideline we have seen in another module. As a first step, you should define your area within the project area where you would like to do a hazard mapping, because it won't be possible to do a hazard mapping for the whole area of your project. You will do that, or it's recommendable to do it. I have here a slide. in areas which are populated or where you have infrastructure like roads, like other kind of infrastructure, to reduce your time you need for the hazard mapping. So probably from your project area will be 5% or 10% of the area where you would really realize a hazard mapping. Then, as Tony mentioned before, after having acquired different necessary data, VCA, soil type, digital terrain model, whatever, you go to this event register to ask people, please show me on a map where you have experienced earlier floods. This is what Tony mentioned. And then to do, I couldn't find the photo from Honduras, but it doesn't matter, to do a transect walk where local people shows you their experiences, but you to look also for the silent witnesses in terrain. And like a third step, you go to the technical analysis. What we have done, what we need much time now, but it is a little bit more complicated. But all of these three steps has the same importance. Not that the technical one is better than the event registry. All of the three are very important to have a reliable result. Okay, Tony, I think I stop here. The definition of critical site, we have to shift it to module 6. Is that okay for you?
I think so too.
Okay, so I hand it to you, Tony.
Yep. Maybe one thing. One thing, but I would like to know from you as well. You know, from that's what with the Swiss Red Cross. That's what's happening all the time. That's usually the case. In the assessment phase, we don't have the resources, neither time nor the money, to do a real, a vulnerability and capacity assessment, etc. The way that we would like to have to do it, and we usually do that in the first year of the implementation phase. However, and I know in some of us, we have the luck or the chance to have a prephase, where we can do that and then use the results there for then to do the project planning. I don't know how it is with you guys, but for us, usually the assessment is very rough, and based on that, we make a project design, and then we try to verify it through a much more robust assessment in the implementation stage of the project. Do you have similar experiences or just very different ones? It's just my question here, and then probably we'll close unless you have other questions.
Well, I mean, it depends. It depends very much on the projects. In general, I would say many projects that I have been working with that were not larger mandates, but mostly own funded or by donations or something in that direction, and also from the general volume of the project, the financial volume. I agree with you. It's often the problem of resources. So and both time, but also capacities of staff and financial resources. And if we have for larger mandates, which I feel, I mean, often there are not so many that have as a primary objective also risk reduction. It's often integrated. There, this can be part. But I, to be honest, I do not have much let's say evidence, not evidence, but I cannot mention many examples where we have done it related to risk reduction. And in hazard, I mean, also related to hazard assessments. Maybe Niraj, you have something to share from Nepal directly. maybe it's more related to integrated water resource management projects or similar. Maybe Neeraj, you have more to share.
Thank you, Yana. But in Nepal also, we normally do not do flood hazard assessment type of thing. I mean, these are basically the preliminary assessment, like Tony said, during the planning period, and when we start working, and then only we do in-depth risk assessment. But basically on climate side.
Okay, so
Where
similar
it's
experience. Huh?
yeah, okay.
Joe, what about in Guatemala? Where you have your flagship. Did you have the luxury to do an assessment in a pre-project phase, or was it integrated also in the first year or so?
We normally have it integrated in the first year.
Okay.
We normally do not have project of that scale that we really have an extra pre-project phase only for the assessments. So normally we have just a rough description of the problem and then do the assessment in a proper sense in the first year.
Okay. So we all cook with water, huh? To use a German saying.
Even if.
Okay, good. So thanks a lot, Georg, for this substantial and very practical, this time very practical deep dive into the art of flood assessment and mapping. I think we got a taste of it, and still have some questions, which is good, because I don't give you the word anymore, Georg, for what's coming in the last module. We will look at the landslide, hazard assessment landslide, but we will also integrate this critical site exercise, right, Georg? Because I think that's a very interesting one here. Probably with a recap with a smaller recap next time from this module, and then with a critical site exercise, and then a second part we would like to open up again for a Q&A. You also noted that in an email that we have provided. Again, we will submit an email with the link to this Google Doc, and please use this opportunity and submit the questions you have with regard to hazard assessment in general. And we would use then the second half or the second part of the module 6 for a Q&A on that. And please, put your questions there just 2 days or so, 2 or 3 days before, so that we can prepare it, that we can group it and be a bit more efficient. Georg, please.
Yeah, just if you fill out the evaluation form, it would be very helpful to know for the landslide module if you would like to have it less technical. In some groups, I had the impression that it was a bit limit in this short time we have available to know the methodology. If you would like to have it more, more qualitative, less quantitative, just let us know to make a presentation as you need or it's what's of your interest.
Okay, thanks. You hinted that I put the evaluation form in the chat. As usual, fill it out, send it in. It helps us even for the last module, and then for follow up, just to learn from those events. So we are past 3 o'clock. Also, what we haven't done today, but we already know, Georg, we already knew that we will not have the time to do that. You actually had some homework from module 3 to a bit to look at. That was a bit getting to know the guideline for hazard assessment. We will also give you this homework for module 6 if you want. You will have a link on that in the follow-up email to familiarize yourself with this guideline, which is actually the basis of this learning journey, at least from the part of Georg's part. Any questions? Any last questions? I don't see any hand. Nothing. Okay, then that's it for today. Thank you very much for your participation. And I'm looking forward to see you on the, what is it, 14th of June, right, Georg? Huh? In 3 weeks' time. Yes, for the last webinar. Huh? So have a nice day and bye for now.
Thank
Thank you
you.
very much. It was
Bye.
really
Thank
interesting.
you.
Bye-bye.
Bye.
See you.
Bye-bye to everybody.